Hello everyone, welcome to my channel, Master Computer Science subject. In this video, we are going to discuss about LL1 parser. It is one of the top-down parser, which is able to cover a very good amount of context-free languages. Why context-free languages? Context-free languages are very much required to define the syntax of the programming languages. Right, now let us know the meaning of this LL parser. The first L stands for left to right scanning of the program in the input buffer, and the second L stands for leftmost derivation of the string or the sentence. What is the meaning of this one? LL1 parser every time looks one symbol ahead to derive the string or to construct the parse tree. That is the meaning of the value 1. In general, we can have LLK parser also, where K marks the number of symbols looks ahead by the parser. Right. Today, we discuss about the construction of LL1 parser with an example. Here we have considered an expression grammar. This is the expression grammar. For a grammar to be parsed by a top-down parser, the grammar should not be ambiguous and the grammar should not be left recursive. If possible, the grammar can be left factored. So in the given example, the grammar is ambiguous. The equivalent unambiguous grammar is this: E derives E plus T RT, T derives T star F RF, F derives E R ID. But the grammar is left recursive. If the grammar is left recursive, we need to remove the left recursion. So after removing the left recursion, this is a grammar we get. Now the grammar is very much suitable for left recursion. In my channel already I have uploaded videos how to remove ambiguity and how to remove left recursion. Those who have not watched those videos, please watch and then continue to solve the problem. Okay, how to construct LL1 parser? There are 3 steps to construct LL1 parser, and the very first step is computing first and follow for all the variables in the given grammar. I have already solved problems with respect to the computation of first and follow also. So let's compute first and follow for the given grammar symbols. First of E. How to compute first of E? Look into the production rule. E derives TE dash. When we construct the parse tree, E can be expanded as TE dash. So out of this, the very first symbol is T. But T is a variable, right? So go and check the rule for T. T derives FT dash. F is the very first symbol when you expand the parse tree from T. So go and check for F. F has 2 options. One is E, another one is ID. And both the alternatives are beginning with the terminal symbol. So first of F is open parenthesis and ID. By the way, first of T as well as first of E also. First of T is first of F. Already we identified first of F, so let us update here. First of E is first of T. We know what is first of T. Now we are yet to identify the first sets for E dash and T dash. What is the first set for E dash? Again, E dash has 2 alternatives. Look into the first symbol alone. Here it is plus. In the second alternative, it is epsilon. So let us update it as plus as well as epsilon. Epsilon is marked by E. First of T dash, look into the T dash production rule. It is very simple. It is nothing but star as well as epsilon. So we identified the first set for all the grammar symbols. Now let us start computing the follow set for all the symbols. Before computing the follow set, let us refresh once again the follow set rules. How to compute the follow set? So to compute a follow of a variable, these are the 3 rules. The first rule says that by default, place dollar symbol in the follow set of S, provided S must be the start symbol. If the production rule is of the format alpha, B, beta, when you try to compute follow of B, really if there are some symbols following B, then follow of B is equal to first of beta. The third rule says that When we try to attempt follow of B, if there are no symbols that is following B, or there are symbols following B but that can be replaced by epsilon, in the sense this beta is vanished, in that case follow of B is equal to follow of A. So these are the three rules we need to remember while computing the follow set. So as per the first rule, the follow set of E contains the dollar symbol, right? Now let's continue to find the follow set of E. So to compute follow of E, I should consider the rules which contains E on the right hand side of my production rule. So this is the only rule which contains E on the right hand side. So when I consider this rule, I have to match my rule against this pattern. So every time I am trying to attempt a follow of B, now we are going to find a follow of E. So E should be matched with B. The prefix of E is alpha, the suffix of E is beta. So after B, there are some symbols that follows. So follow of E is equal to first of beta. So follow of E is equal to, in fact, it is first of close parenthesis. First of any terminal symbol is that terminal symbol itself, that is a close parenthesis. So we have identified one more symbol which is to be updated in the follow set of E. So let me update here as the close parenthesis. Now let us compute follow of E dash. To compute follow of E dash, we have to consider two rules. One is E derives TE dash, another one is E dash derives plus TE dash or epsilon. Why we are considering these two rules? Because both the rules contain E dash on the right hand side. So first let me consider the very first rule, which is E derives TE dash. So E dash is matched against B because we are attempting to compute follow of B. Prefix of E dash is T. In fact, there is no suffix after E dash. When there is no beta that follows B, what is the rule? Follow of B is equal to follow of A. What is B here? It is E dash. A is nothing but E. So follow of E dash is equal to follow of E. If I want to update as per the rule, what I have to update in the table? Follow of E dash is equal to follow of E means I'm just copying and pasting it here. So I hope this is understood as of now. Now let's continue to explore one more rule. There is one more rule, right? Which contains E dash on the right hand side. E dash derives plus T dash. We can ignore this epsilon here. E dash derives plus T dash. So E dash derives plus T dash. So here also after E dash, there are no symbols to follow. So as per the third rule, follow of E dash is equal to follow of E dash itself. Follow of E dash is equal to follow of E dash. So there is no change in the follow set. So what is a follow set we obtained for E dash? It is very simple. The dollar symbol as well as the close parenthesis. Right? Now let's continue to compute the follow set of T. To compute follow set of T, we have to consider these two rules, which has T on the right hand side. The first rule is E derives T dash, and the second rule is E dash derives plus T dash. When I consider these two rules, first let us explore the very first rule. E derives T E dash. In fact, there is no alpha part. T is matched against B. After B, there are some symbols which is following this B. When there are symbols following B, what is the rule to compute the follow set? Follow of B is equal to first of beta. So as per the rule, follow of T is equal to first of E dash. So what is first of E dash? We have already identified in the table, it is nothing but plus and epsilon. So we have to consider this plus and epsilon as it is. Follow of t is equal to first of e dash plus and epsilon, but we cannot include epsilon in the follow set of any symbol. First set of the variable may contain epsilon, but none of the follow sets contain epsilon. So what to do with the epsilon? This e dash, first of e dash is equal to epsilon, right? So replace this e dash by epsilon now. When we replace this e dash by epsilon, what is the rule we are obtaining? E derives t. Now e dash is vanished. What is follow of t? Follow of t is equal to follow set of e. Follow of t is equal to follow of e. So when I apply to this rule, the symbols what we are getting is dollar as well as a close parenthesis. Now combine both the sets. As a whole, the follow set of t is computed as what? It contains the dollar symbol as well as the close parenthesis as well as the plus symbol also. So these three symbols, let us update in the follow set of t. Let us update in the follow set of t. Okay, next we have to compute the follow set of t dash. To compute follow set of t dash, again we are considering these two rules. T derives f t dash and t dash derives star f t dash. This epsilon we can ignore because it does not contain any t dash on the right hand side. So first let me consider the very first rule, t derives f t dash. Really there is no symbol following this t dash. So follow of t dash is equal to follow of t, which is nothing but dollar plus and the close parenthesis. Now let us consider the second rule, which is t dash derives star f t dash. Here also after t dash there are no symbols following it. So follow of t dash is equal to follow of t dash. So there is no change in the identified symbol set. So follow of t dash is also equal to follow of t, which is dollar plus as well as the close parenthesis. Let us update that value in the table. So follow of t dash is same as follow of t. Right, now we are supposed to identify the follow of f. To compute follow of f, we need to consider these two rules which contains f on the right hand side. T derives ft dash and t dash derives star ft dash. So let me fill the rule matching against the pattern. T derives, here f should come and this must be the t dash. T derives ft dash. So in fact after f there is t dash. So what is follow of f? Follow of f is equal to first of t dash. What is first of t dash? In fact it is nothing but star as well as epsilon. But in the follow set we can't update epsilon, right? So what do we need to do? Remove this epsilon from the follow set. At the same time, replace this t dash by epsilon. Now this is a resulting rule. If you explore this rule, how do you compute the follow set? Very simple. Follow of f is equal to follow of t. Follow of t, which we have identified as dollar symbol, close parenthesis, as well as plus. So now when we combine follow of f together, we obtain in fact the four symbols. Okay, but till now we have explored only the first rule. Let us explore the second rule also. What the second rule says, t dash derives, star should appear in the alpha part. This is f and this is t dash. Here also I should update it as t dash. So what is follow of f? Follow of f is nothing but first of t dash. Yeah, we are getting the same rule. But first of t dash contains epsilon, so this t dash will be removed from the rule. Now if you try to identify what is follow of f is equal to follow of t dash also. So let me write it here. Follow of f is equal to follow of t dash. So as a whole, if we update, these are the four symbols which we have identified as follow of f. Now let me update all the symbols in the table where we are entering the first and the follow set for all the symbols. This is how we have to compute the first and follow for all the variables. Now let's move on to the second step in the construction of LL1 parser. Now let us see the structure of the parsing table. This is the structure of LL1 parsing table. This is the signature of this parsing table. M refers to the mission, A refers to the row value, and the small a refers to the column values. The capital A reminds us of the variables, the small a reminds us of the terminals. So all the variables are nothing but the rows, and all the terminals are the columns. Apart from the terminals supported by the grammar, we should include one more terminal, which is nothing but dollar. This dollar is the right end marker of the input string. If the input string is kept in the input buffer, the dollar indicates the end of the string. So this is the structure of the parsing table. So what we are going to fill in the parsing table? We are going to fill the grammar rules into the parsing table. So for every grammar rule, the address may be like this: e comma id, a comma plus, e comma open parenthesis, or sometimes a t dash comma plus. Somewhere in the cells, we are going to fill the rules. So to fill the rules, we have already computed the first and the follow sets. We are going to make use of that. Okay, now let's look into the grammar. This is a grammar. E derives te dash is the first rule. So where can I fill this rule into the table? Consider the rule and find what is the first set of this E. First set of the E contains the open parenthesis and ID. Right. So E comma open parenthesis is the address of the cell I meant in the table. Then E comma ID, I'm going to fill the rule E derives te dash. So let us do that. E comma ID as well as E comma open parenthesis, we have filled the rule E derives te dash. Now let us move on to the second rule. What is the second rule? E dash derives plus te dash. At the same time, E dash derives epsilon. So there are two rules in fact. E dash has two alternatives. So we have to consider it as two individual rules. So first let us consider the rule E dash derives plus te dash. Again consider first of E dash. What is there in the first of E dash? Plus as well as epsilon. But when you consider the rule E dash derives plus te dash, from that rule, the first set what you have obtained is plus. Epsilon you would not have obtained from the rule E dash derives plus te dash. We would have obtained epsilon from E dash derives epsilon. So update the rule E dash derives plus te dash at the address E dash comma plus. At the address E dash comma plus. So here we are going to update the rule E dash derives plus te dash. Right. But whenever epsilon appears in the first set, go to the follow set. So what is the follow set symbols for E dash? One is dollar, another one is close parenthesis. So E dash comma dollar and E dash comma close parenthesis, update the rule E dash derives epsilon. So E dash comma dollar, E dash comma dollar is this. Here we are updating the rule E dash derives epsilon. At the same time, E dash comma close parenthesis also we are updating the same rule. So whenever epsilon appears in the first set, that is the only moment we go for the follow set. Okay, now let us consider the next rule in the grammar. What is the next rule? T derives ft dash. So where I have to update the rule in the table? Consider the first set of t. first set of t contains two symbols. One is open parenthesis and another one is id. T comma open parenthesis and t comma id. I have to update this rule. T comma open parenthesis and t comma id. I have to update this rule. Yes, done. Now let us move on to the next rule. What is the next rule? T derives star ft dash and t derives epsilon. There are two rules. In fact, there are two alternatives for t dash. So we know that t derives star ft dash would have given the first of t dash as star. From this rule only, first of t dash is nothing but star we would have arrived. So update the rule. T dash derives star ft dash against or in the cell t dash comma star. So we have updated. We have another rule, right? T dash derives epsilon. Where to update the rule? Whenever epsilon appears in the first set of t dash, go to the follow set. What is the follow set? Plus dollar as well as close parenthesis. Against all these cells, we have to update the rule. T dash derives epsilon. T dash derives epsilon. This rule is to be updated against close parenthesis, t dash comma close parenthesis, as well as t dash comma plus. So we are done. Only the last rule is there. Again, the last rule I have split it and into written as two separate rules. F derives E. You consider that. Out of this rule, the very first symbol, the first set of F, what we would have obtained, it is nothing but the open parenthesis. So F comma open parenthesis, we need to update the rule. F derives E. F comma open parenthesis, we need to update the rule. F derives E. Then F comma ID, we have to update the rule. F derives ID. This is how we have to fill the parsing table. If the parsing table is filled, we can move on to the next step. Before continuing to parse the string, let us understand the LL1 parser block diagram. So this is like control unit. In fact, this diagram is similar to the pushdown automata, what you people have studied in theory of computation or automata theory. So this is the like control unit, which is equivalent to the CPU. There is an algorithm inside it. That algorithm has built the table. This is the parsing table, which we built now. And this is the input buffer. In the input buffer, the input string is kept. Now the parser is reading the input string, starting from the first character till the end character. The end of the string is marked by $. That is why we have included this $ in the parsing table also. You can see that $ is included while filling the parsing table, which indicates the end of the string. And while scanning the input from left to right, character by character, it may push or pop some symbols onto the stack. Once it reaches the end of the string, the parser will say yes or no. Yes is nothing but it has recognized the string. No is for not recognizing the string. So parser is equivalent to pushdown automata. Now let us see how to parse the string with an example. Now let us see how to parse the given string. The given string is id plus id. To indicate the end of the string, there is a $ symbol also. To parse a given string, to do the third step, in fact, we depend upon the second step. What is the second step? We constructed the LL1 parsing table, isn't it? Right. So now look into the table in which we are going to parse. In the diagram itself, we know there is a stack and there is an input tape, which we call it as input buffer. And this two columns are just for our understanding. The last column is compulsory parsing action. In fact, while writing the answers, you can skip this third column. The stack contains the start symbol because from the root of the parse tree, the parsing or the derivation of the string begins. It is a top-down parser. So always stack contains the start symbol of the grammar. In the input buffer, the string given is id plus id star id. This is the string being given, right? Now just consider the symbol, what is available at the stack and what is the first symbol the parser is going to read. So E comma id. E comma ID, in fact, is the cell address, right, in the parsing table. You just check what is there in E comma ID. It is nothing but E derives TE dash. Just I consider the rule. So based on the rule only, we are going to do the parsing action. So E comma ID, from the parsing table, the parser selected the rule E derives TE dash. Now what it is going to do? In place of this E, the right hand side of the rule is pushed onto the stack. Again, while pushing onto the stack, E dash will be pushed first, followed by T. So in place of E, the right hand side of the rule is pushed. While pushing, the rule is reversed and gets pushed. Okay. Now what is available at the top of the stack? T is available. Still, it is pointing to the first character of the input, which is nothing but ID. ID put together is a single symbol. So what is T comma ID? Again, go and refer to the table. T comma ID makes us to select the rule. T derives FT dash. So let me copy it here. So now what is the next thing we have to do? In place of T, E dash is available as such. In place of T, we are going to replace with FT dash, the two in reverse order. So first T dash, then F. So this is the way we have to push the symbols onto the stack. Right, after pushing it, once again check what is available at the top of the stack and what is the input symbol is pointed by the parser now. It is pointing F comma ID now. So what is available in F comma ID? F comma ID contains the rule F derives ID. So let me copy and paste the rule here. F derives ID. Now you know what is to be done. The stack contains E dash, T dash. In place of F, I have to replace ID. ID is a single terminal symbol. Even though it contains two letters, you treat it as a single terminal symbol. Okay. Now what is available at the top of the stack? What is the input pointed by the parser? Top of the stack is ID. Input pointed by the parser is also ID. So the symbols are matching. ID comma ID, right? So top of the stack and the input pointer matches. If that is the case, pop stack and advance the input pointer to point to the next input symbol. So if that is the case, what we have to do, this ID is removed. Since it is we are advancing to point to the next symbol, I have removed this ID from here. Since I cannot show as a pointer, look into the earlier step. This ID is to be popped from the stack, and since it is matched, now the advance, you have to advance a pointer. The parser is reading now the plus. So I have removed this ID in the next column. Now it contains only ID and dollar. So what is available at the top of the stack? Continue to do the parsing now. T dash comma plus. When T dash comma plus, what is the entry in the table? T dash comma plus is nothing but T dash derives epsilon. T dash derives epsilon. So what we have to do, in fact, in place of T dash, we have to replace it by epsilon. When T dash is replaced by epsilon, T dash is vanished. So still the parser is set to read plus ID and dollar. Now check top of the stack and the input symbol. Top of the stack contains E dash and it is still pointing to plus. So go and check what is the rule for this cell. E dash derives plus. Contain the rule E dash derives plus T dash. I just copy the rule and paste it here. So what is to be done at the next moment? We know that in place of E dash, this plus T dash is to be replaced. But while pushing, I have to push it in the reverse direction. E dash T plus. So what is available here? Plus ID dollar is available in the input buffer now. Now you see the top of the stack and the input symbol both are same. What is available here? Plus and plus, isn't it? If that is the case, we need to remove whatever is available at the top of the stack. At the same time, advance the input pointer to point to the next symbol. So what is the status of stack now? The stack contains $e-t, plus is vanished. Here also plus is vanished. The parser is yet to read only the ID. Right now you check what is the rule for t comma id. Go and check what is the rule for t comma id. T comma id contains a rule t derives ft dash. So let me copy and paste the rule here. So we know what is the next step. The next step is, in place of t, we have to replace it by ft dash, isn't it? So while replacing, first we have to push t dash, then followed by f. This t is replaced by t dash f. So now the input tape contains this id as well as dollar. Now you check what is f comma id. F comma id allows you to select the rule f derives id. If that is the case, this f will be replaced by id. So let me copy and paste. If this f is replaced by id, the top of the stack and whatever is pointed by the parser in the input tape, both are one and the same. Top of the stack is also id, input tape also contains id, so we need to pop whatever is available at the top of the stack, isn't it? So now the stack contains $e dash t dash. Now id is also read by the parser. Now the input buffer contains only the dollar symbol. So what is t dash comma dollar? That we have to know. That we can come to know only from the parsing table. What is t dash comma dollar? T dash comma dollar is t dash derives epsilon. So t dash derives epsilon. It means this t dash must be replaced by epsilon, isn't it? So now the stack contains only e dash. Of course, the input buffer also contains only dollar. What is e dash comma dollar? E dash comma dollar is e dash derives epsilon. E dash comma dollar is nothing but e dash derives epsilon. So that is a rule we have selected now. Now what will happen? This e dash is also replaced by epsilon. So stack contains only the dollar symbol. Input buffer also contains only the dollar symbol. If the top of the stack is dollar and if the input buffer also contains dollar, it means what? The parser has completely read the string. In this case, we can say parsing is very much successful. Parsing is very much successful. This is the way the string is to be parsed. You can try parsing the strings with some more examples also. I hope you would have understood this. Thank you.